guys, welcome back to my YouTube channel. So today we are going to solve day 23 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 2707, extra characters in a string. Okay, so let's read the problem statement first. So in this problem we have given a 0 indexed string S and a dictionary of words. You have to break string S into one or more non-overlapping substrings such that each substring is present in dictionary. There may be some extra characters in string S which are not present in any of the substrings, and we have to just return the minimum number of extra characters left over if you break up string S optimally. Okay, so see this example number 1 here. This is my string given to us, okay, and this is a dictionary given to us. So here if I just consider this substring, so I will see that this lead is present here in my dictionary. Okay, then after that this is the remaining part that I need to check. So this S code is not there in my dictionary, but this code is there in my dictionary, right? So this code is there in my dictionary. So this S is a remaining character right now, right? So I don't see this S anywhere. So we can break string S into two substrings, lead from index 0 to 3, okay, and code from index 5 to 8. There is only one unused character at index number 4, so we just return 1 here. Okay, so we have to just return the minimum number of extra characters left over if you break up S optimally. Okay, so actually there are two ways in which we can solve this problem. One is using a top-down approach, recursion and memoization, and one way is bottom-up approach, okay, using dynamic programming. So I'm going to explain both the approaches in this tutorial. First I will solve this problem using recursion and memoization, okay, that is nothing but my top-down approach, and then I'm just going to convert this recursion and memoization code to bottom-up approach, okay, bottom-up approach dynamic programming. Okay, so I'm simply going to use this code only to convert it into DP code. Okay, so just watch this tutorial carefully. First let's understand this recursion memoization, okay, how I'm going to solve this problem. So this is a string given to us, right? Leads code. Okay, so here if I write this word leads code, so here let's say that this is nothing but my index number 0, right? Index 0. So let's say my I is at this position, okay, and let me just give the indexing here: 1 2 3 4 5 6 7 8. Okay, so here let's say my J is at this position. Okay, so this L is there in my dictionary? No. So let's move my J forward. Okay, so then my J is going to move forward. This LEE is there in my dictionary? No, it is not there. So let's move my J forward. Okay, so my J is right now at this position. Okay, let's say. So now this lead is there in my dictionary, right? This lead is there in my dictionary. Then after that what I need to do? I need to search in this particular part, right? I have completely found this solution in this part. Now I have to search in this part. Okay, so here my starting point is at this index. Okay, I is at this index. So here also I can have two options. I can have two options. If I want to treat this L as extra character, or if I don't want to treat this L as extra character. Okay, so if I want to treat this L as extra character, then here I have to pass return here 1 plus, okay, this is 1 plus, if this L is extra character, then I have to search in this part, right? In this part. So here let's say this is my helper method, and in this helper method I am just passing this index, okay, from 1 until next until n I have to search. Okay, if this L is extra character, okay, if this L is extra character, then I am writing 1 and then remaining portion of my string. Okay, but if it is not the extra character, then what I am doing? So then I am just moving my J forward, and here I found one substring which is there in my dictionary. Okay, if this L is not extra character. So okay, so here I found this, but then after that I have to search in this position, okay, j plus 1. So until j plus 1 is right now this index I right. So then after that I need to search from j plus 1 position to complete string. Okay, so here I just want to show you the two different things that we need to check if we want to exclude this current character. Okay, if we want to treat this as an extra character, okay, extra character, or if we don't want to treat it as an extra character, then this is what we need to do. Okay, two options we have, right? So just understand it like this, we have two options, okay, whether we want to treat this as extra or no. Okay, so here next time I am searching from this one, okay, starting from this one, okay, j plus 1. So here also I have two options now. I want to treat this as an extra, or I don't want to treat this as an extra, not extra. Okay, then if I treat this as extra, so here I have to search like this 1 plus, in this helper method I am going to pass starting from 5 to n complete. Okay, and if I don't want to treat this as an extra, so here I have to search like this. Now right now it is starting from here now, so I have to search this complete as code. It's not there, this string itself is not there. Okay, s code is not there. Okay, so let's ignore this part as of now, but here let's see. So 1 plus, then this 5 to this end index, I will find one substring which is there in my dictionary. Okay, so here 1 plus code, it is there in my dictionary, so from here I am just going to return 1. Okay, 1, and in this part you will see that there is nothing. Okay, there is no such string. Okay, so for this I can simply say that 5, return 5 here. Why 5? Because I will treat then these all the characters as extra, right? S C O D E 5. Okay, total 5. I will treat like this 5 as extra, and here I will just get 1 as extra, this s as extra in this part. Okay, so here this is my string na, scored. Okay, so here I am saying that treat s as extra, and then you will find the complete part. So this is one part, here from here I will get 1, and here I am completely searching this string, then I will return 5 now, because I will treat then all these 5s are extra. But here we have to return the minimum number of extra characters left over if you break up s optimally. So definitely I will take this as my output. Okay, minimum, so I will pass this here in the higher part 1. Okay, and here also 1 plus this complete I will search. Okay, so I will get some output here, right? Let's say I will get some output here. So here from here also minimum, what is minimum? So let's say this y is a value that I'm getting from here, which is nothing but 1, we know. And here let's say something that x is coming. Okay, let's say, so out of x and y we have to return the minimum to the top level, so definitely 1 will be there. Okay, in this section we will get like this. Okay, so first I will get lead, and then I will search in s code part. Okay, then here lead is there. Okay, and then I will treat this as extra, then I will search like this, so only s will be the extra. Okay, minimum. So this is my recursion tree. Okay, so I am going to write the code for this one, simple, exclude and include. Okay, then I will also show you how recursion is going to work here. I will just give the dry run with the debug statements. Okay, so let's first write this simple code. Okay, whatever I have explained here, include and exclude, nothing else. And also let's do one thing, this is dictionary of string arrays, right? So let's convert it into set. Okay, and in the set I will just add all these strings, and then it will be easy for me to search in of one time complexity, right? I will just simply say if my set dot contains this particular string, then it will simply check, right, and return if it is there or not. Okay, so let's convert it to my set. Okay, and let's do that. Okay, but definitely I will get time limit exceed error, so we will do the memoization then. Okay, and then we'll see if with the memoization our code works fine or not. Okay, so let's write this simple thing first. Simple thing, code is going to be very easy for this one. Okay, so here uh, here what I'm going to do, let's first calculate the length of my string. N is equal to s dot length. I have calculated the length of my string. Then I am saying let's convert this dictionary to a set. Okay, so here let's do that. Okay, so here I'm going to write set, and in the set I am just going to pass string, and let's name it as set new hash set. Okay, this is done. And then let's iterate over all the words in my dictionary one by one. So int I is equal to 0, I is less than dictionary dot length I plus plus, and here in the set I'm just going to add. Okay, set dot add dictionary of I. Okay, done. So okay, so this is done. Okay, in the set I have added this dictionary. Then here I am just going to simply return one helper method. Okay, I will call. So here let's say return helper, and in this helper I am just going to pass my string s. I am going to pass my set. Okay, and then I am searching from this 0 index, right? So let's say this is my starting point. So in the starting point I'm just adding 0. And what is the total length of my string s? Because I have to iterate over all the characters one by one. So here I'm just going to add n. Okay, so this is clear, right? No issues till now. Okay, and now let's write this helper method. Okay, this is also going to be very easy. So private int helper, and in this helper I'm just going to pass my string s. Okay, I'm going to pass this parameter. Okay, string s, and I am going to pass this set. Copy this, paste it here. Then here I am passing 0. 0 is nothing but my starting point. So here I am just going to write int start, and here n is nothing but the length of my string. So here let's pass this int n. Okay, now inside this I have two options every time. Okay, but first let's say if my start, okay, start I am checking from this index, then this index, then this index, then this index. Okay, if I reaches to the end, then definitely there is no missing character. Okay, so from here if my start becomes greater than equal to n, then return 0. Okay, so I hope that this base condition is clear. If start is greater than equal to n, then simply return 0. Okay, done. And here now if I don't want to include the current character, okay, so here take one variable int result, and I don't want to include this L, I want to exclude it. Then 1 plus remaining portion. Okay, so this is what I need to do. So 1 plus, again call this helper. Okay, and in this helper we need to pass my string, we need to pass my set, and now this time my start is going to be start plus 1, right? And then my n will remain same. Okay, if I'm excluding it, and if I'm including it, then my j is going to start. Okay, so let's initialize j from here only. Okay, maybe L is there now, maybe L is there in my dictionary. Okay, so let's start j from here, then we are moving j one by one to the next position, next position, next position, until I found one substring which is there in my dictionary. Okay, so here let's do one thing. For int j is equal to start, okay, this is include part. Okay, j is less than n and j plus plus, and here I am saying let's take one string cur, and in this cur I am just going to pass s dot substring, and my substring is going to be start from starting index, and it is ending at j plus 1. Why j plus 1? Because this is exclusive now. So if my j is here and I want to see this lead, so I have to pass 0 and this 4. Okay, 0 and 4 simply means substring from 0 to 3. Okay, lead this 0 1 2 3. Okay, 4 is exclusive in this substring method, right? So that is why we need to write j plus 1 here. Okay, this is done. Then I will check if my set contains this current string. Okay, if my set dot contains this cur, okay, then I told you now, if my set contains this cur, then I have to check in the remaining portion, right? In the remaining portion, this s code portion. Okay, so here what I'm going to check, I'm just going to update this result as math.min. Okay, we need to take the minimum, right? Result is equal to math.min. Okay, in this part I need to check, so it will be nothing but the math.min of these two different portions, right? Exclude and include. So if it is exclude and if it is include, that we need to check. Okay, so here I'm just going to pass the result, and here I'm just going to call my helper, and in this helper method I'm going to pass my string, my set, and then after that I'm going to pass my next position. Okay, so next time this is going to start from j plus 1 now. J is here, then next time it is going to pass from j plus 1. Okay, in this part. Okay, so here I'm just going to pass j plus 1 and n will remain same. Okay, so since we are considering this exclude and include, okay, we need minimum. Okay, so that is why I am updating my result like this, math.min result, okay, with the exclude or with the include. Okay, whatever the minimum is there, I will just add that, and in the end, here my for loops end, here just a return result. That's it. That's it. Easy. Now let me run it. Okay, let's see if there are any code issues, and if there are no code issues, then we will see whether we can submit this solution or not. So right now there are some there are some code issues, so let's fix that. So here dictionary spelling is wrong, I think, right? Dictionary, here it is wrong. Why? Diction, then here a should come now. Okay, so now all the test cases has been accepted. Okay, so now let's submit it. Let's see whether we can submit it or not. So now this is going to be interesting. See, we are getting time limit exceeded error. 171 test cases passed out of 2028. Okay, so many test cases are there, right? So now what? So can we do the memoization? Because I'm calling this helper method so many times, so let's store the value. Okay, maybe I'm calling this helper method again and again in my code. Okay, but let's see how how this recursion is working. Okay, so here this solution is with memoization. Okay, so let's first do the memoization. Okay, let me add the memoizations here. Here see one thing first, the string length is 50, 1 to 50. So okay, so let's create one memoization array, and let's give that length as 50. Okay, 51, we will say 51. Okay, int t is equal to new int, and here I will say 51. Okay, so it will include all the values from 50 until 50, right? So this is done, and here let's fill all the values in this because only my this start is changing every time, so this will work. A single array will work because only start is changing. Okay, only one index is changing, right? So let's fill all the values in the starting to this array as -1. Okay, so here I'm just going to write arrays dot fill what we need to fill this t with -1 value. Okay, this is one line, and then after that here let's store this result in t of start. Okay, whatever the result I'm going to get here, t of start is equal to result. Okay, and here I will check if my t of start value is not equal to -1. Definitely that simply means that I have filled this value. Okay, so t of dot start is not equal to -1. Then we have to simply return t of start. Okay, that's it. Now let's run the code. All the test cases has been accepted. Now let's submit it. So see, our solution is accepted right now, right? So here what I did, let me just zoom it. Okay, so I added this line. Okay, and then I fill my array with -1, and then after that every time whenever I was getting this result, so I was storing that result in t of start index. Okay, and here I am simply checking if that index, okay, value is not equal to -1. Definitely that simply means that it got updated in the past, so simply return that, no need to calculate it again. Okay, so that's a simple meaning. So now our solution is accepted. Okay, so now let's see how this recursion is working actually. Okay, so I don't think that in any other tutorial you will see how this recursion is working with dry run. So, okay, so here let's see it. So this is my string s. Okay, so this let's say this is nothing but my index number 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, and index 8. Okay, so here we are going to start at index 0 first. Okay, so here this line. Okay, so here I am doing this. So here let me just do one thing here. Let me just copy this part. Okay, paste it here. Okay, so now see this part. So here I am calling this int result is equal to 1 plus helper of s set start plus 1. Okay, so initially start is 0 now. Initially whenever I pass the value first time it was 0. Then my start will become 1. Okay, then after that again I am calling int result is equal to 1 plus helper with 0. Then I am going to call this helper with 1. I am going to call this 1 plus helper with 2, 1 plus helper with 3. Okay, start is going to update every time I'm calling this. So index 4, start at index 5, start at index 6, start at index 7, start at index 8. Only this line is executing right now. Then after that when I reach at this position 8, then my start will become 9. Okay, so when my start becomes greater than here, so it will return 0. So I will get, for this specific part I will get my result as 1. Okay, initially after treating extra at index 8 we will get a result as 1. Okay, so this is my string now, leads code, leads code. Okay, so here this is part is nothing but for extra. Okay, so if I'm just treating this 8 as extra, okay, after treating extra at index 8 my result will be 1. Okay, then after that I am going to search in this part. Okay, so here in this part I am going to run one loop which is starting from index number 8 and 8 until my j is less than n. Okay, so only this e I will check. So this e is not there in my current string. Okay, if it is not there then I will just update my t of this 8 as a result value. Okay, I have updated this. Okay, so here after that I am again going to return. So at this, if I treat both these de as extra, okay, if both these de as extra, then from this part I will get my result as 2. Okay, and then I will check if d is there in my this dictionary. No, it is not there. So I will simply update my t of 7 as 2. Okay, then I will see this word. So here if all these 3 are extra, so after treating extra at index 6 I will get result as 3. Okay, now I will search for this one. od is there in my dictionary? No, it is not there. Okay, in this part I am searching now. Okay, so I will not find any substring, so I will just update my t of 6 as 3. Okay, now it's interesting. One thing here. So at 5 what will happen? So at 5 if I treat all these are extra, so I will get my result here as 4. Okay, I was getting 4 here. Now after that I am going to start searching. Okay, so I will see that this is there in my dictionary. Okay, if this is there in my dictionary then I'm updating my result as mat.mean of result. Previous time my result was 4, and in the helper method I am going to search again helper s, so s set and j plus 1. So j plus 1 simply means that somewhere at here j plus 1. Okay, because I am taking the substring until here now, start and j plus 1 until here code. Okay, complete. So my j is there. So for this part this helper method is going to return me 0, right? So 4 and 0, but is minimum, 0 is minimum because this code is there. There is no extra word. So here after matching dictionary word code we get result as 0. Easy. And I am updating my t of 5 as 0. Okay, so this is how you need to do. So just go over all these lines one by one. Okay, but I hope that you guys are clear. After matching dictionary word delete, result is equal to 1. Memoization t of 0 is equal to 1. Okay, this is what we need to return. That's it. Okay, easy. So just go over this line. Let me just minimize the size of this one. Just take the screenshot. Okay, whatever you need. So just copy this, see this, and then this part. Okay, that's it. So here this is how step by step my recursion is working. Okay, so I hope that you guys are clear with the recursion code. Now I'm going to simply change my recursion code to the DP, okay, to the bottom up approach. Okay, so what I will do, so let me just do one thing. Let me just copy this, let me take the screenshot for this code. Okay, then I will show you how I'm going to change it to DP. Okay, so this is my code. Okay, so here now right now I'm going I'm going to solve this problem using bottom up approach. Okay, so here this is my string na, leads code. Okay, so leads code, what is the total length? 9, right? So here let's create one DP array of length 9. Okay, so this is nothing but index number 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8, index 9. Nice. Okay, so I need to find the extra characters in my string leads code. Okay, this complete string I have to find. Okay, which is starting from this index 0 until n minus 1. Okay, this is nothing but n minus 1 index, right? Total n is 0, 1, 2, 3, 4, 5, 6, 7, 8. This 9 is nothing. Okay, there is nothing here. Okay, so I will show you what I'm going to do here. So definitely I need my answer at this particular index. Okay, so what I will do here, so at this index I need some value, right? So definitely to fill this value I must know the extras in this substring. I must know about this value. Okay, I must know about this value to fill this value. Okay, so what I will do here, I'm just going to start from this particular index. Okay, I'm going to start from this particular index, and here inside this I'm just going to check. Okay, so here this value I'm going to write it as, okay, so if I want to exclude it, okay, if I want to exclude it, so my result here it is updating as 1 plus helper of next part. Okay, so here if I want to exclude, so I'm just going to write it as dp of I. So let's say this I is nothing but 8. So here it is going to be, if I want to exclude, so 1 plus dp of I plus 1. So this value is 0 itself, right? dp of I plus 1 is 0, 9. Okay, so here this is 0 only. Okay, so I will treat this as 0 only. Okay, so dp of I plus 1 is 0. So 1 plus 0 here is 1. Okay, so 8 dp of 8 I am getting 1 if I want to exclude it. Okay, this is what I need. And if I want to include it, then I am just going to simply use this code, right? So I am going to start from this, j is equal to start, j is less than n. I'm just going to use this. Okay, here I have updated this helper to dp of I plus 1, and here I just change this portion to dp of I. Okay, so I am going to fill the values from here. Okay, then here, then here, then here. So okay, so this is done. So here for this portion, how I'm going to check, so I will take a minimum of dp of I. Okay, if I want to include, then math.min of this line I'm going to write math.min of, and in the result I'm just going to pass previous value of dp of I, which I get using exclude. And here in this part I'm going to do, I am just going to pass dp of j plus 1, right? dp of j plus 1. Simple. I'm not going to use recursion here. Simple, these two lines. And in the end I will just get my result here at this particular position. Okay, because I am starting from here now, 8, then 7, then 6. Okay, I'm filling all these values one by one, then checking this one, filling this value, then checking this one, filling this value, and then checking this one. Okay, so here let's convert the code first. Okay, so here I don't need this memoization, so I'm just going to remove this part. And here okay, let's go over this. Int n is good as dot length. I don't need this line. I'm just going to simply remove it. Okay, then after that I am creating one set. Okay, I need this set, no issues. Then here after I'm returning this helper. So instead of this in the end I'm just going to return dp of 0. I have told you that my answer will be stored in dp of 0 in the end. Okay, I will get my answer at here because I need the answer for this complete string now. And now inside this what we need to do. Okay, so inside this let's create one dp array, int dp array, a new int, and here after that just pass n plus 1. Okay, I am adding n plus 1 because I need one extra index which I will store it by 0 by default. Okay, by default it will be 0 now. So here this is done, and then after that I have to run one loop, okay, which is starting from this n minus 1. So total length is 9, so 8 from here. So I need to fill this value first. So here I'm just going to write for int I is equal to, let me just zoom it, int I is equal to n minus 1, I is greater than equal to 0, I minus minus, and inside this what I need to do. So inside this let's me just copy this line. Okay, copy this, paste it here. I told you that we need dp of I now, so here I'm just going to write dp of I, and here instead of this helper I'm just going to write dp of I plus 1. This is done. Then we need this for int j. Okay, we need this part. Okay, let me just copy it, paste it here. For int j is equal to, here let's take I now because I'm using I now. So j is equal to I, j is less than n, j plus 1, string current I will take, it is starting from I to j plus 1, and here if my set dot contains this, and then I will update my dp of I. Here I need to write dp of I to math.min of dp of I, and here instead of this I'm checking for j plus 1. Here I will just pass dp of j plus 1. Okay, I will do the dry run on this dp as well. Okay, so just wait. So this is done, and now we don't need this part. That's it, we don't need. So now see, I will just delete it. That's it. I changed my recursion memoization code to this dp code. Okay, so I don't think we need anything else here. Let me check. Okay, let's run it and see if the encode issue, then we will see if there is anything else required. So yes, so here variable I error cannot find the symbol. Okay, so let's see, int I is equal to, here j is equal to I. Why it is not coming? Why I am writing it outside? It should not be outside now. Here this above one is for exclude and inner one is for include. So here I should end here now, this one. So let me just format the code. Okay, let's run it again. So all the test cases has been accepted. Okay, so now let's submit it and see. So now let's give the dry run on this. Okay, how this is working. So here this is my string s, right, and this is dictionary keyword. So initially we are filling dp of 8 now. Here see I is equal to n minus 1, dp of 8 as 1 plus dp of 9. So dp of 9 value is 0, so I will fill my dp of 8 as 1. Then we will process dp of 7, I will fill this value. We process dp of 6, which is nothing but 1 of dp 1 plus dp of 7. This is exclude part now. Then dp of 5 will fill 1 plus dp of 6, it is 4. Okay, but at dp of 5 I will see that this will also execute this part because I will find one string. Okay, so I will find this word code. Okay, when I find this code from index 5 to 8, so I will update my dp of 5 as math.min of dp of 5. So previous value of dp of 5 is 4, and here after that I will write dp of j plus 1. So j plus 1 value is going to be 8 plus 1 9. So dp of 9 is nothing but 0 initially. So out of 4 and 0 I will fill this as 0, dp of 5 is 0. Okay, then we will fill dp of 4, dp of 3, dp of 2, dp of 1, then dp of 0 I will find one more word delete. Okay, so here when I found this word delete, then I will update my dp of 0 as math.min of dp of 0. Dp of 0 is nothing but 5, and here dp of j plus 1. So 0 to 3 I will find one word, so I will write dp of 4 here, right, j plus 1. So at 4 what was the value? dp of 4 value was 1. So 0 and 1 which is minimum, 5 and 1 which is minimum out of 5 and 1, so I will update it as 1. Okay, So this is going to be my final DP array. Okay, and for the time complexity, so this is going to run for dictionary times. Okay, so let's say O of m for this one, and let's say this is running n times, right, in reverse direction, and then this is also running n times in worst case scenario. Then inside this I am finding this string current. Okay, and here I'm calling this substring, which is also running let's say for max n times. Okay, if the length is very long. Okay, so overall time complexity is going to be O of m plus O of n cube. We can ignore this m because n cube is very larger. So overall time complexity I will say O of n cube. So right, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.